Hey guys, today we're going to write explicit rules for geometric sequences. Now, yesterday I taught you the recursive rule, and the recursive rule is a rule that's definition is based upon the previous term. Remember, we did the fancy way of writing previous term of g sub n minus 1. And in this rule, you had to write out all of the numbers in the sequence in order to be able to find a position that is further away. So like if you wanted the eighth position, you would have had to list out all 7 in order to be able to get to the eighth. Well, today what I'm going to teach you is the explicit rule, and that's a rule for a sequence that is defined by the position of a value. So no longer will you have to list out the entire sequence. You can instead just jump to that position number and know exactly what that value is. So this is going to come in handy when like someone is asking you to find the 100th term, because you don't want to list out 99 terms so you can get that 100th term. Instead, you want to be able to use this rule. So the rule for the explicit sequences will still deal with the common ratio. And from yesterday's common ratio the R stands for common ratio. And remember, that's that second term divided by the first term. And so maybe write it out like that: second term divided by the first term. But I like to just write it shorthand, G2 divided by G1. Now the rule is G sub n, remember that's the way we start out our rules, and is equal to G sub 1, that's the first term, times R, which is your common ratio. And this time, instead of it being a subscript, it's in the exponent part, n minus 1, where G1 is your first term still. R is your common ratio. And n is your position number in the sequence. So for instance, like I was saying 100 while ago, you would just take this term 100, you would plug in position 100 in for the n, and then you would be able to solve the equation and know exactly what that value was. So let's go ahead and put all of this into an example, okay? We're going to talk about Alyssa. And first, we're going to go off of what we learned yesterday with the recursive formula, so I can show you that you're using the same information. Alyssa shares a funny video on social media. The video was viewed 10 times that day. Each day during the rest of the week, the video gets 3 times the number of views as it did the day before. All right, so if I'm looking at this, I know that it's 3 times the number, and I know that's important. I know that the first day it gets viewed 10 times. So day 1, this is our day, it gets viewed 10 times. So all I did was label it day 1, the viewing. We're going to figure out day 2, day 3, and day 4. If day 1 is 10 and the video gets 3 times the number of views, you're going to take that 10 and multiply by 3 to get to 30. Then you're going to take that 30, multiply it by 3 to get to 90. Then you're going to take that 90 and multiply it by 3, and that's going to be 270. Now you can see rather quickly that this is a geometric sequence because you're multiplying by the same number every time. Now that is the definition of a geometric sequence. Now a recursive sequence, which again is what we did yesterday. Remember, recursive, you have to have 2 lines. You have to tell me what your first term is, and then you have to give me the formula for it. So my first term, I'm going to write G1 is equal to 10. You gave me that information already. And so what I'm going to do is I'm just going to highlight this so you can see where I'm getting all of these numbers from. Now, the next part of that line for recursive rule is G sub n is equal to, if you remember from yesterday, it's the R, which is your common ratio, times G sub n minus 1. So my R value, that is what you're multiplying by every single time. And they told us in words that it's 3 times. We saw down here that you're multiplying by 3 every time. So my R value is 3. So I'm going to plug that in here. And then it's going to be times my previous term, g sub n minus 1. Now we know that. Now, explicit rule, that's what I'm teaching you today. So the explicit rule, if you look at the rule here, it's g sub n is equal to your first term. Guys, you already have your first term. That was 10. So if I write a 10, that's coming from this point right here. That's my first term. So I'm going to put a box around it so you guys can see where it's coming from. Then it's times my r value. We already talked about the r value is 3. So 3. Then in the exponent part, we're going to have n minus 1. Now, sometimes that r value is a fraction, and when it is a fraction in the explicit rule, you're going to need to put parentheses around it. But in this case, it's not, so you don't have to. Now, if I highlight it so you can see where everything came from, you'll see that the 3 and the 10 are found in both the recursive and the explicit rule because they are using the exact same information, just in different orders. So now it says, how many views would the video have after the 6th day? If you were using the recursive formula, you would have had to multiply by 3 2 more times to get to the 6th day. Now, the 6th day is your n value. So we know that n is equal to 6 because that's like your term number. So if I plug that into my formula for explicit rule like I'm teaching you today, g sub 6, that's plugging in for the n, is 10 times 3 to the 6 minus 1. Now, when you type that in Desmos, it is rather difficult, at least it is on my phone, when I'm typing that in, to keep everything up in the exponent part. So what I'm going to show you to do is just do that math in your head. You know how to subtract 1 from something. So I'm going to type 10 times 3, and then I'm going to hit this AB button. Remember, that's your exponent button. And then that's going to raise it up to the 6 minus 1 is 5. So your answer, your 6th term, g sub 6, is equal to 2,430. And remember what that is talking about. It's the number of views. So I'm going to go ahead and write the word views. Now you could have found it the other way, is if you multiplied 270, oops, let me come down here, 270 times 3, that would have given you the 5th term, which is 810. And then if I take that number times 3, that'll give me the 6th term. So 810 times 3, that's 2,430. And notice it's the exact same answer. You can do it either way, especially when it's these smaller numbers, what your term number is. But when you get to the higher numbers like 100, you're not going to want to list that all the way out. All right, example number 2 is very similar to the example number 2 from yesterday, whereas I'm giving you a graph. Anytime you see a graph, you immediately create the sequence. So my first term was 1,215. My second term was 405. My third term was 135. My fourth term was 45. My fifth term was 15. My sixth term was 5. I notice that I'm decreasing. Actually, that kind of looks like an exponential curve, but that's not what it's asking. It's asking you, A, what is G1? Well, G1 is my first term, so I know that's 1,215. And I've been highlighting or putting a box around my first term just so you guys can see where numbers are coming from when I write the equation. Now, part B, it says, what is the common ratio, which is R? So I know R is equal to, we talked about it earlier, it's the second term divided by the first term, and I notate it as G2, 2 meaning second term, divided by G1, 1 being first term. So my second term is 405. If I divide that number by 1,215 in my calculator, in Desmos, if I type 405 divided by 1,215, it gives me this long decimal. Remember, do not just write 0.3 repeating. You need an exact number. So I'm going to use the fraction button like that, and it does switch it over really easy to 1/3. So I know my common ratio is 1/3. Now it needs me to write an explicit rule for the sequence. I'm going to rewrite that formula down here so you can see it again so I don't have to keep moving the paper. So that's G sub n is equal to the first term times the common ratio to the n minus 1. So as I write my explicit rule, it's G sub n is equal to my first term, and my first term was 1,215. That is my first term, and I got that from part A. Times my R value. My R value was found in part B, and that was 1/3. And remember what I said about a fraction. If you have a fraction, please put parentheses around it because the n minus 1 belongs to the entire fraction. And if you don't put parentheses around it, the n minus 1 would only belong to the 1. So if there's a fraction, make sure you put parentheses around it. Now it says, what is the term in the 8th position? Remember, n is 8. So if you plug that in, Desmos, G sub 8 is equal to 1,215 times 1/3 to the 8 minus 1. Plugging it in Desmos, I'm going to show you how I do it. I have 1,215. I open my parentheses. I type 1/3. I click out so I can close my parenthesis. Now I'm going to arrow up, or not arrow up, I'm sorry, click the AB button, and that gives me the exponent. And again, I can't type that in there, so just do in your head. 8 minus 1 is 7, so I'm going to put a 7 there. That gives me 0.5 repeating. That's not an exact number. I want the fraction. So go ahead and push that fraction button, and that number is 5/9. So to write the answer, you would write G sub 8, because that means the 8th term is 5/9. So this would be my answer to that question. All right, part 3. I've showed you up here on example number 1 that the recursive rule and the explicit rule use the exact same things. They both use G1 and they both use the common ratio. So if I'm given the recursive formula down here, I can switch it over to the explicit rule rather quickly. So the explicit rule, again, here's the formula for it, is G sub n is equal to G1. They tell us that G1 is 0.25 times the R value. Remember in the recursive rule, the R value sits in front right here. So I'm going to take and multiply that by 2, and then I'm going to raise it to the n minus 1. Now again, I'm going to highlight so you can see where every number came from. The 2 came from the beginning, and it goes here. This one is my first term, and that came from this information right here. Now, either rule you can use to create the sequence. I'm just going to use this one up here. It's the previous term one. They give you 0.25. Now, I get excited and I end up doing too many. So I'm going to give myself blanks. This is my first term, second term, third term, fourth term, and fifth term. So they're telling us to multiply the previous term by 2. That's what this rule is saying. So I'm going to take this 25 and I'm going to multiply it by 2, and that gives me 0.5. Take that half and multiply that by 2. So take 0.5 times 2. That gives me 1. 1 times 2 gives me 2. 2 times 2 gives me 4. So now I have successfully completed this lesson. Hopefully now you can write an explicit rule for a geometric sequence. Today you're going to have an assignment on a worksheet, and then it'll be due tomorrow. I hope you all have a fantastic day.